Hello? Anusha, how are you?
Good morning. I just wanted to tell you I won't be able to attend by chat today.
Okay.
Yeah. Just like my environment isn't suitable for me talking.
Okay.
So like during the meeting I'll just be typing if that's okay.
Oh, that's fine. Yeah. Yeah.
Okay. Cool.
Good.
Yeah.
So, how are you doing?
Pretty good overall.
Good.
Yeah, there's a heat wave coming here, but I'm getting ice cream, so.
Oh, good.
Yeah. How about you? How are you doing?
Well, I'm doing pretty well.
Okay, that's good.
Yeah.
Yeah.
So, yeah. Any follow up on the critical period stuff that you had?
Not at this time, no.
Okay.
I did want to think about that document we were all going to make,
Okay.
and what we were going to put in as the important information for the critical periods. I did want to think about that so I could get started on it. Yeah.
Okay. So, maybe create an outline.
Yeah, that'd be really helpful.
All right. And so the document is for well, I mean, I don't know. I don't remember.
I think Jesse mentioned it's like an overview of important critical periods, kind of just documenting the main ones.
Okay.
Yeah.
Yeah. So that would be like a catalog, maybe, or I think I remember this now.
Like that.
Right. Well, yeah, we'll work on that. I think that'll be a good project. We can create a, the best way to do that is to sort of create an outline document and then have your, basically think about what the examples are. Every time you run across an example, you put it down as in the outline, and then you have, then we can sort it later.
Okay.
Yeah. Organize
it. That sounds good.
Yeah.
Hi, Jesse.
Morning.
How are you?
Okay, it's been kind of I'm not totally out of the woods yet, but I moved this week. I finished moving. I changed a bunch of my plans. I signed a job offer. It's just been a crazy week of. I think this is my last full week of massive transitions. I mean, the UK stuff is one thing, but as far as adjusting to broader normals, I think this is a major week, the last week of that. So I've been really exhausted, to be honest with you. I've been just maxed out, and I look forward to getting a little bit more time with the lab and just back to normal because my normal hasn't really been anything like my normal for a while, and it's a bit draining. So I think I'm on the doorsteps of returning to that or making that a new place somehow. I don't know how to say it, but I'm in good shape. It's just been a lot, really.
Well, that's good. I think, and you're really seeing the fruits of your efforts, I think, over the past couple of years where you're getting, a new sort of regime in your life. So,
yeah, that's exactly right. A new regime of sorts, yeah.
So, how are you, Angela?
Hey.
I'm doing pretty great. Yeah, just finished tea with my in-laws. Life is glorious. I'm finishing the boot camp that I started in 2019, but then I ditched halfway for Columbia, and my diploma came. So yeah, just been working on startup stuff, and also, I think that's about it, really.
It's a lot. So yeah, well, welcome to the meeting. This week has been pretty busy, I think, for everyone. It's, you get into the groove of things, and you have to. It's just like it's a lot of things happening, which is always, it's good to have a lot of things happening. It's just being able to manage it and make sure that things get done that maybe you overlook because you're doing all this, all this stuff, and so. So I guess today we're gonna start with the Slack. I have a Slack review. I have some things to talk about, like in terms of our progress with presentations and things like that, which are going to be coming up this week. We have put a Medium post up. I don't know if people saw that.
I did.
Yeah. And then, we'll have some more information. I have a couple things I want to show presentation-wise. So, first of all, did anyone want to do something? I mean, we'll do it after the Slack review, but did someone want to present or give updates? Oh, hi, Erin. Okay. So let me start with the, let me share my screen here. All right, so we have, can you see my screen? All right. Let's see. I don't see a lot in the Slack this week. I think people have been pretty quiet in here. I know there's a couple of pieces of news that I wanted to get to. I'm trying to make sure we cover everything. So this is the thing I'm going to present later. This is the ABM AI conference. This is the Agent-Based Models conference that's coming up on Tuesday. And I tweeted about it, so it's in the Twitter feed of the lab. And it's basically this Metabrain models presentation. The presentation is at, I believe it's 2 p.m. Eastern on Tuesday, this coming Tuesday. And so you have to be registered for it. The registration is like $5, but there's this Tuesday and Wednesday event where the event is called Inverse Generative Social Science. And then this, I think it's a series of lectures or lecture series, and then they have this Agent-Based Models conference that they're hosting. So this, I'll talk about this later, but that's coming up. That's one of the things coming up this week. Let's see if NeuroMatch has anything. No, but there's news there, and I'll get to that. Let's see, Open Chat usually has something. I don't see anything. I don't know if we already talked about that last week. I don't think there's anything new in papers. Research questions. VR, nothing new there. Not really sure where this was placed. But Krishna, okay, here it is. In the general channel. So Krishna got accepted as a TA to NeuroMatch. Yeah, he got accepted to the deep learning course that they have. So this year they have a computational neuroscience course, and then in August they have a deep learning course. So he applied to the deep learning course, and he got in, and I see a lot of people responded. And yeah.
That's great. I know he's had a lot of things to deal with recently as well, so the fact that he got that, and the fact that I think he's been looking for, looking for something like that to come along, and I feel like he totally deserves it,
Yeah.
So it's just, it's a great thing for him, and, cool for the lab to be there, to support him, and to do that. But, I think it's a wonderful thing that he, I think it will really be a great thing for him, and open some doors, and we all NeuroMatch. Actually, I'll be on camera in a moment, but I have my NeuroMatch t-shirt, so that's a big deal too. but it's partly in celebration of that, but also because fresh on my list because I'm moving, I actually have access to it very easily with that. But I'm really curious how we'll go out to the deep learning course. Will be great. That's the one that's later in the. That's after the main one, right? After the computational neuroscience one?
Yeah, the computational neuroscience is in July, and this is in August. So.
Okay, well that would be great. That'll be great.
Yeah. So I think that's all we have in the Slack channel. Then I wanted to get to. So I mentioned that there's 2 conferences this week coming up with us involved. It's the Agent-Based Models course, which is a 30-minute presentation, and I have it up. I'll show it in a bit. But then there's also this Cultural Evolution Society conference that we discussed a couple weeks ago, where the presentations were recorded, and now they're on the YouTube channel. But now they're going to have the actual conference, and so that's later next week. So I got into this is the conference portal. So they have this. This is the portal that they're using. It's Underline.io. I don't know. I've never used it before, but it's a way to manage. I noticed that the online conferences now are using, this year, as opposed to last year, using platforms like this. So I was at the INCF assembly, and they used platform. I think it was called Brella or something like that. So it's very similar to this, where you have opportunities to interact with people and access the schedule and all that. So you have the program for Cultural Evolution Society is that it was supposed to take place in Japan, so it's kind of like the Sigkai conference that's shifted towards Japan-friendly times. So that means often that it's not optimal for North America. So it starts in LA. It starts at 4:45 in the morning. New York 7:45 in the morning, which isn't horrible, but it's just and then the first day they have plenaries, Q&A sessions, discussion sections, and so our talk is in the second discussion session on Thursday. So it's roughly noon Eastern time. I think probably about late afternoon in England, and so that's where you go to the session, and both the talks are in this discussion session too. It's like an hour-long session where people can come and discuss your work with you. So they view it online and then they discuss it with you. This is going to take place in GatherTown, which is a virtual. I think that's what they were using for the Women in Computing conference, if I'm not mistaken.
Yes, and some other major conferences have been using it too. GatherTown is nice, but I'm curious about some of the other new things that they're doing there too.
Yeah. So then there are going to be a lot of these Q&A sessions are like talks that are, I think, a little bit longer, and then they have question, they'll have the talk and then the question and answer afterwards. Then, of course, they have the plenaries. So, and then it goes through Friday. And so, about the conference, so they're going to have, you can ask questions directly through this platform, or through the GatherTown link, or I guess they're going to do some Zoom talks as well. So, those will be live. And then, let's see. I don't know if they have the conference schedule here. Let's see if they have it. I got to log in. I'm not going to log in for that. But if you read, they have a lot of talks here. So I'm not going to. I'll probably go through them next week at next week's meeting. We'll talk maybe about this and about the ABM conference. So that should be fun. I'll report back in the Slack to tell people what the feedback was and everything. But it should be a good experience. Next week's going to be pretty busy for me, and then we'll we'll see what happens from that. It should be, I think it should be well received. Speaking of events and conferences, I did put this on the Medium. So this is the dispatches from the Emergent Interaction Workshop. So this is something I presented about a couple weeks ago, where we did this Emergent Interaction Workshop. We did the paper for it, and then the event happened, and we talked about the event. And I summarized a lot of the notes here, put a lot of the links to papers. So this is, I might do this for maybe the Cultural Evolution Conference or the ABM or both. I think this is worthwhile because it gives you gives a good summary of what's going on.
Yeah, I think these are great, especially for when everybody can go there and do everything. I'm filling out here. Basically, yes, I approve of this.
Yeah, okay. Are you putting on your NeuroMatch t-shirt or?
I do have it on. I'm just trying to get I'm getting used to my fake digital nomad life right now. So, but yes.
All right. So yeah, this was actually really good. A lot of these different talks and kind of pull up some of the things I couldn't really get to visually in the presentation that I gave in this group. A lot of the links to the papers, and so that's good. Do we have any questions about any of that or any comments? Okay. I think I forgot. Well, let me go back to the Slack review. I think I forgot a couple channels here. Ethics, Tech, and Society. I think I missed a couple things in here. So this was a discussion with Jesse and Erin. This was last Saturday, I think, after the meeting. So Erin and Jesse had a conversation about the project she'd like to work on. And then this was a thing about, we're going to make a document that focuses on themes she might want to explore in a lit review or annotated bibliography, look at qualitative and quantitative aspects of the issue. The lit review will help narrow down things, and I think along with the Summer of Data and Data SciML, which is the two sort of parallel initiatives that we have going on, there can be some discussions about the stats and data techniques ahead. Erin may start with presenting a couple papers or concepts. Me to reach out to Bradly. And then key names that came up, Ruha Benjamin, Timnet, Abiba, and Sarah Brown. And then let's see, I said yes. And then Angela said, dude, Ruha's abolitionist tech writings inspired me so much in 2020, I basically went down that route. So that was 3 likes on that. So any thoughts about that? I don't know if we lost on that. I think it was just another instance, but oh, you're muted, Jesse.
Can you hear me now?
Yeah, a little low though.
Okay. This is gonna work quite right. There hasn't really been any updates on that, but also NeuroMatch. Yeah. But I think that's definitely the next step for Erin and for the ethics and society team in general. And I would even like for Anusha or for Angela, if there's something specific that you want to focus on in that sense, we can try to tailor something out for you. But I just haven't really had the time to have as much constructive organizational efforts about that yet. So if there's specific things that you think, I know you mentioned the data trust stuff and some other things, topics for the data privacy conference, but if there's something you want to work on in a project-based sense, think about that and let me know, and we can either meet with potentially Erin as a team or just have a conversation elsewhere.
Why the quotation marks?
I don't know. We are a team.
The JAE team.
Yeah, I actually have been thinking of ways to come up with different ways to talk about the ethics and society team in general, like SET or whatever team. Like, so the team name is open to discussion in and of itself.
The good place.
The good place. That's certainly it's a TV show. But yeah, if you have any specific ideas about that, let me know. Because now that I'm settled into a somewhat transitional phase, at least it's being settled, and I'll have a little bit more to put into this. So I apologize to everybody because I haven't really been able to focus in on the developmental aspect that needs to happen for some of these things right now, but it will come.
We understand. You're in flux, and we get it.
Yeah.
Yeah, so that's good. Yeah, I think that like annotated bibliographies are often pretty valuable, just to get a sense of the literature and where it's going, and this kind of fits into the Trajectories work as well, where you're doing this, trying to figure out where things are going or where things have been, and getting a sense of like who's really kind of in each little area, and then not assuming that there's certain like buckets, but to see where the broader trends lead you. So that's all very useful, and it's something that can be of great benefit to the whole community, not just our group. So we'll have to talk more about that in the future, how to do that and how to what the best way to approach that is. Okay, so why don't we go into updates now, and if people want to give updates on things, or if you want to talk about anything that's on your mind.
I don't know if anybody else has anything particularly they want to say. I feel like there are things, I don't know if Erin's going to be using chat or voice here, or whichever, but I think we did have a good conversation, and I did not I believe, if I remember from last weekend, there was kind of what was put in the Slack was a pretty good update, and I think that progress for us was just following, like, we have the plan, and then honestly probably after, I've been quite, after this meeting again, there'll probably be another discussion about that. So I have another meeting at 2:30 for the startup people that I'm talking about, but between then, if anybody wants to talk after the meeting, there probably will be at least a part of an ethics team discussion, and then either later tonight and tomorrow, Sunday, I'm going to have a lot of availability for, like, one-on-ones. Or if there's anything that, even with you, Bradley, like, I know I've kind of been all over the place, but if there's anything that you want to have, like, a specific talk about or focus on for the upcoming presentations that you think I should highlight or focus on, it could be in just a Slack meeting or a other meeting otherwise. Like, basically I'm like fully available today and tomorrow, and it'll be great to like just sit down and go over stuff. So I intend to be working on all these things directly after the meeting. So.
Okay. Yeah, that's good. So yeah, maybe we'll touch base on Slack later today, or So yeah, so I mean, I guess it's like we get into these. We get down into these like deadlines and kind of working on stuff, and then our lives come into play, and then we have to kind of figure out where we are. I think we're all set on the presentations for this week. I don't know what the ABM conference will be like, but I think I'll go over those slides and we can actually discuss them here. The Cultural Revolution society stuff. That's just going to be like an informal chat. So I don't know if there, I don't know what would be, there's not much to prepare for that. But that's going to be open. And then, I don't know, maybe we'll, well, actually, we do need to talk about the cognitive science trajectories event.
Oh yeah, and like definitely the docker for this weekend is updating the website and all the people who want to be involved with the Cognition. That's something that should be. I think maybe we should. That can be something that I try to schedule for like a more bigger discussion, maybe next week or something. It's just a general Cognition futures update, including that. The Coexistence 2021. For those who, I don't know if I can easily find this. Ooh, no, this is not work. Oh yeah, cool. I can share my screen, right?
Yeah.
Let me share myself. Oh, here we go. Oh, weird. It doesn't give me an option here. Okay, that's different.
For what?
Like it just went immediately sharing my screen, and I could like choose a window or whatever. Because I have like different monitors and setups here. But anyway, you can see this.
Yeah.
So this is what we're at. Can I do this? Kind of. All right. So this is Coexistence 2021. Well, let me show this. This doesn't look quite right. This is the main Cognitive Science Society page. Coexistence 2021. Should I get? Can I show? Yeah. This is the main conference. This is like the big name conference in cognitive science. And it looks like this is the theme of it this year: comparative cognition, animal minds. Is that right?
Yeah.
So this is kind of where we are for it. Total Research Institute. They're coming up again. All right. So it's end of July, supported by the Vienna Cognitive Science Hub. This is what these firm speakers are. Fisher, more. Okay. And there's a bunch of other people. All right, just to get to just a little bit overview of the conference. So these are like affinity and discussion groups, and I believe we have. I know they finalized our time, and they said we have like 90 minutes. Is that right?
Yeah, about 90 minutes. So that's the date. 28th, about 90 minutes.
Yeah. So 4 p.m. Eastern time on the 28th.
Yes.
It's us, and we're kind of going to be doing a. I don't know if you had any particular ideas. We'll talk more about this next week. So this is more of a preview than a discussion right now, I think.
Right.
But like, what I was going to try to do is sort of do an outline of the general concept of cognition futures and just trajectories of cognitive science, and we will need, for anybody who's interested in the lab, like if your name's not on this list, don't worry about that, because you can be involved or on there. And what we're going to need is like, I think creating some really general trend lines, and just having I think basically we have like an opportunity to have a discussion and maybe like a plenary table, and then just open discussion for a while. Is that kind of the sense that you got, Bradley? Or
yeah, usually the way these things work is you sort of give a introduction to the idea, very short, and then you get into maybe some more technical things, and then you have an open discussion where people do stuff. And we could even do it like where we have like an introduction to the idea, and maybe like 20 minutes, and then get into like doing a group exercise or interactive exercise. And where we're doing, like you said, maybe drawing some trend lines out, but that would probably have to be canned to some extent, because you don't want to try to figure out what to do. You have 90 minutes, so you really have to plan a little bit. Like maybe have like a session where you go in and you draw out like something. You label. You have everything sort of in your notes, and then you're labeling things in real time, and then you elicit some conversation from people. You say, let's fill in the blanks here.
Yeah.
That's basically the way I would do it. Just so you get people into it, to give them a frame of reference, and then you get them involved in what you're doing, and then.
Yeah, and there will be a lot. That will be a really interesting and maybe challenging, but fun event to do. So anybody who's interested in contributing to that idea-wise or function-wise or how to arrange the event, just know that that's totally open for involvement, and that'll be a major thing that we're going to be focusing on, and we'll be updating that in updating the website as well, but that's going to be kind of a major shift that's developing in the lab. And also, like, honestly, I feel like I think there might be a nice way to sort of have maybe a little piece on developmental AI, if you want to kind of like promote that there. I think I'm going to do like a minor, if it works out, I might have like a very small allusion to or presentation to like the state-of-the-art AI stuff that I'm working in, and kind of show that relates to things. Okay, Erin, good to have you stop by. Good luck with all the stuff.
Thank you. There
will be some interesting things to kind of sprinkle in, like almost. It almost could be like a 90-minute like program of like, here's a little bit about developmental AI as like almost like a commercial, like almost like an intermission between like the major chunks of stuff. I don't know if that will work in reality, but in my mind that was sort of an option. But yeah, that's all. This is kind of more just a, hey, think about this for a little bit, and then we can talk about it later. Oh!
Yeah, Ashka's here.
Gosh. Hey, good to see you. I don't know if you can talk right now, but hey.
You're muted.
I think.
Yeah.
But great to hear. Great to see you.
Yeah.
Did you want to say anything? I think you were gotten into the program or something. I don't know if you want to chat it out or if you can type it.
There we go.
Oh, there you go. Hi.
I don't have anything much to say about right now, but yeah, it's good to join you guys after a long time.
Yeah.
Yeah. Nice to see you again.
You joined the lab like earlier this year or like last year?
Last year, during the year March, I did join.
You've been around for some time, so it's great. It's been months since we've seen you, and we're all happy to see you again.
Yeah. Nice to see you again.
Yes.
Okay. I think that's pretty much all of my updates. Like I said, Ethics and Society team will be having some kind of meeting with us later on. And also, like, I don't know what your current schedule is, Anusha, but if you're available to talk about some of the things, and like, I think you were talking with Bradly at the start about the periodicity stuff and working on like building out the foundation for like the lit review and the annotated bibliography stuff. So we can talk about that whenever it's good for you too. So. But that's all I got to say this week.
Okay, yeah. That's good. Yeah.
Other than like, I guess I'll say Anson and I separately. I think I'll get there like a day before him or so. But the plans are still moving forward for everything to go with the UK, so that'll be interesting. And like I might meet with Charlotte from the Philosopher's Web Cafe.
Oh right, yeah.
She has like her birthday's coming up soon, so we may be in the same area. there's a bunch of people in London that I'm going to try to meet, and who I don't think I don't think Miguel, I know we talked about Miguel Nunez.
Yeah.
I think he's not going to be in Europe. I was going to try to connect with him at some point. And there are a few other things that, if there's anybody in Europe, or especially the UK, that would be good for the lab to talk to, or whatever else, I'm going to try to do some like networking for the startup. And also just like I'll be doing it really won't be like a fun thing. Oh, I guess there's this, that Angela person is in Europe. None of that. But like anything that, if you have any ideas, either me or Anson should be like aware of, or Anson will be there for, I think, longer than me as well. So if there's anything like any conferences that are coming up in the long term, or hey, we have contacts in XYZ that we might want to reach out or do something, just keep that in mind, because we'll actually have some on-the-ground presence. Even like, I don't know if, I think, is Daniela in Italy, or is she in the UK? I forget.
I think she's in the UK, actually.
Okay, I should talk to her.
I might reach out, yeah.
Yeah, so there can be, in like, maybe we'll make a Slack channel or something about like, oral in the UK or something, like,
Yeah.
like just for like ideas or contact or something, because that, I'm sure we'll be coming across like at least some people we've already worked with there, so just to keep that in mind. But outside of that, that's all my update.
Yeah, that's great. Yeah, we need to have like we don't really have geographic groups here because it's like we're usually pretty virtual. But yeah, that's always good to sync up with people if they're in different parts of the world. If you're in the same part of the world or whatever, So I think why don't we have like a cluster of people in North America, a cluster of people in Europe, England, Europe, and then India. It's usually the way, that's usually our three clusters of people, but so that's good. Let me check the chat here. So yeah, Erin had to leave. She watched the recording. Thanks for attending. And then Anusha says, I have an outline for what information we want in the critical periods document lit reviews. We were talking about that earlier. And, it's like I told her, it's not, it's good to make an outline, but, to plop things into the outline as you go along is good to have, just to make sure that you don't lose anything. Because I know we get like, the way it tends to work is you run across something in a paper and you get excited about it. And then, like, you forget about it. And then, like, oh, what was that thing? So if we could just keep everything in the document. And if, we change the outline or we change the scope, I mean, usually I want to define the scope early, but I think critical periods is a field where there's not enough scope to, like, lose yourself in. I think there's some basic papers that we can, like, hit, some classic papers maybe, and then some lines of inquiry in the literature. So I know that, there's some main authors, a couple main authors that I am familiar with. And then there's some, areas of research that they've kind of followed on. And then, maybe there's some areas where, papers that don't necessarily fit into that but are interesting. So again, we can use this as like the cognitive trajectories, or the trajectories approach to kind of characterize a lot of this. So, just prepare the outline and then we'll start to fill it in. And then, we have I think in the Discord team, we have a channel on bibliography. If you want to check that out, I'm not sure what state the bibliography's in, but I tried to put a lot of stuff in there. And I have a list of papers in my records somewhere that are like the full list of things that we've talked about. So I'm not sure how much is in the bibliography, but I would definitely go through that channel and check each one and make sure it's in the initial list.
Yeah, and I don't know. I think there is. I don't have. I'm not going to really get into my Zotero right now, or the lab Zotero.
Yeah.
But I think we might already have a Zotero folder about it. But we could honestly create a specific folder to this project, whether it's like Anusha's project of like this thing specifically, or just critical periods in general. I think most people are kind of familiar with Zotero or mentally reference managers, but having that as an external reference manager is a good component to have that we can just reference easily, and using that see. Yeah, I think that's Anusha said. She can check the channel, and guidance on names are important topics to get started. Yeah, I think that what we can do after this meeting, or now if you want to, basically make a shared Google document, and we can have anybody who wants to be on this can, by the way, but Bradly and I can both be on the document and leave comments, or like put in some key names and start fleshing it out, and start putting some structure to the document. I think that'll be like a good notes document, kind of like what we did for the ethics, the New York Celebration of Women Computing. Just kind of creating a big, massive document. Something that had like contains basically a database, and then we can start extracting specific things from it. Like if we want to make a blog post or a paper or a presentation from it. So that's kind of the first infrastructure step, and we can people can just between that or in the Slack, if people have a specific a name they think is important, or a concept, or list of critical periods, whatever.
Yeah. Yeah, in terms of like names and topics, we have people like Takao Hench, who I think you'll see that name again and again he does a lot of stuff with like the molecular basis of critical periods. So like, what kinds of molecules or genes are being expressed, opening back up the critical period windows and things like that. Then we have like Frankenhuis, I think. There are a couple other people who do things more with behavior. So there's a focus on behavior. And then, there are other paper. If you go through some of the papers, just, take a look at if you see the author come up more than twice or three times, they probably have a research program in it. So you can look up and see what their specialties are. Originally the Discord channel was started around like sort of a life and simulation approach to critical periods. So we were trying to figure out, we wanted to get some more information about what people were doing in the study of critical periods. So it was like that sort of an investigation with that sort of eye towards a computational approach. So I didn't really find, there hasn't been that much on computational approaches, but I think we might have one or two things in there. And certainly it's something that isn't really, I don't think people really hit it too hard in terms of, writing a paper on here's a computational characterization of critical periods. But that's another area that might have some detail. But yeah, we'll go through the papers, and if we find like names that come up again and again, those are going to be the names that you want to keep an eye on and follow up on. And keep in mind that welcome. And keep in mind that we can cast our net pretty broadly. So if there's a new area that no one knew about, we should include it. We should make sure that we do literature search. Not only critical periods, but maybe some adjacent topics like like developmental timing or something like that, and see if there's stuff that's relevant in there. Sometimes, they don't give it the name critical periods, but that's basically what they're studying.
What I would like to... One thing that comes to my mind saying this is like some, this kind of fits with the trajectory stuff, but just like... And this would be interesting for like developmental AI specifically also, but sort of a comparative, like I think about the Paul Kaisek talk, and if you don't recall that was kind of about stages in evolutionary development and how looking at like what things were sort of conserved or where branches split in that. So looking at in a sort of comparative analysis sense, this is not necessarily the main thing for critical periods, but it can be an interesting layer or lens for it. But like, how do the compare humans to apes or chimpanzees or different mammals, or maybe is there anything like a critical period, and can you, what are the limits of a critical period? Like I don't, does a fly have a critical period? Does a reptile, or like, are there anything equivalents in terms of just, if not a critical period, can be broad classifications of stages of development, like egg, hatchling, growing, adult, mature, like even just in a basic sense of what those developmental periods are across groups, might be kind of an interesting thing to just think about or reference in the broader context of, here's evolutionary periods of agents being, agents like where they are in their development, across everything that's living, believe it or not, has different stages of being alive or not being alive. And, finding ways to weave that narrative into specifically the critical periods focus as maybe the backdrop might be interesting.
So there are a lot of, especially when you start getting into insects, there's a lot of stuff that is sort of allied to this. Like, so there's the study of life history, which is across life. So it's not just concerned with development, but it's like all the stages of life. So you'll have like, life history is like, going from like the egg to the adult to like the aged form. And so like a lot of organisms have a different sort of, some of them have very short or non-existent developmental periods. Some have a very long developmental period. So, this is all sort of the life history timing. And then, you experience things maybe in your youth and, or your adulthood that are, you have plasticity and maybe adulthood in some species more than others. Then there's, of course, metamorphosis and polyphenism. So metamorphosis is where you have, in insects especially, where, you have this development of an organism, and then it maybe goes into a phase where it goes into a cocoon, and the cellular structure actually decellularizes parts of the organism. And then it reemerges, there's some morphogenesis, or there's some differentiation of the cells back into a new phenotype. And then you have this, so you think about the caterpillar turning into a butterfly, going into a cocoon and turning into a butterfly. What's going on in the cocoon is that large parts of the body are being recycled into new types of cells and newly differentiated cells. And then it becomes this new phenotype. And it's that life history transition. It's like going from it's not a pupae because the caterpillar is actually like, an organism, but there's this transition. So there's that aspect. And I know there's some literature on metamorphosis, but they don't really link it to a critical period. But that doesn't mean that there aren't connections there. And then there's polyphenism, which is where you have, in development usually, you have this transition, into different states in development. So in C. elegans, the worm that the diva worm group is interested in primarily, there's this thing called the Dower period or Dower stage of development. So the worm, it hatches from its egg and it goes through these larval stages, and then it gets to a certain point. And if there's it's triggered by environment. So when the environment's very difficult, or it's sparse, there's not a lot of nutrients, or it's in a drought or something like that, they go into this Dower stage, which is where they grow this really thick cuticle and they sort of hibernate, and that's something that they can maintain for probably weeks to months. And their metabolism is really slowed down and everything. And then they can emerge from this period and continue on with development and into adulthood. Now, under different conditions, the same worm can just continue on its larval cycle and end up in adulthood in a much shorter period of time, and then it lives its life. So you see all these different things going on in development. Now, critical periods, of course, are this timing where there's an acquisition of things. And so we think about that in terms of the sort of, we think about it in terms of like in humans learning and memory. So we're learning things in the critical period. But there's a lot going on with respect to the critical period in terms of like, the underlying things like environmental, switching depending on your environment, or, your access to information, or even metabolism can shift the critical period. And there's that literature on the critical period window, the length of it and the breadth of it, and all that can be actually modified in the laboratory, but it also gets modified in evolution because you get different conditions that a species is subject to, and it determines its acquisition state. How long can it acquire a lot of information? Maybe it doesn't need a critical period, or maybe it needs a very acute critical period. And then we've also talked about different sensory domains. So there's a visual critical period, and that can be distinct from like a sensory motor critical period, where you have the acquisition of like movement information rather than like visual information. So it's like, for some reason, those things are maybe in some species independent. And so that probably has a lot to do with maybe their ecology, or maybe like, the fact that maybe they go through metamorphosis. And so there's a reason there. So, I mean, that's a lot to think about, but, those are the kinds of things we want to kind of think about, like, what are the allied areas and how do they kind of fit into this model?
Yeah, I'm creating the document, like a basic outline of the document now. What you said kind of like you mentioned the concept of like life stages or life history.
Right.
What is that? How should I write that in the document? Is there a specific term for that?
Well, let's see. So the way it's stylized is like that usually, and with a hyphen, and then that's a literature. There's a literature on life history. It's generally, you'll find it in a lot of evolution and ecology journals. So they don't talk about it a lot in psychology. They talk about the issues, but they don't give it that name. But I think like behavioral ecology, they talk about it a lot. They talk about it in, ecology and evolution, where they're looking at the actual life stages of an organism. And, again, when you move away from humans, maybe to insects or some other, like lizards even, or fishes, it gets really interesting because there's a lot of diversity there, and a lot of different modes of development and things like that. So
yeah, and it'll take a little bit for how we want to structure some of the things here. And I know that's going to be some of the work after this meeting. Like, this is a really good little bit on here, but I think I think getting a clear path forward for what to do, and like there's annotated bibliography, but like having some, I think it'd be good to have a little bit more brainstorming about, as we do annotated bibliography, what are the themes we want to highlight. Like you can kind of do like a summary, review of a specific paper, but then thinking, all right, well, regarding the theme of life history, what does it say? Regarding the theme of critical periods, regarding the theme of like, mammals versus insects, what does it say? Like having some specific things to look at, and you find what you look for, but also you can find things that maybe come up out of the blue. So, but I think there's a way to structure this a little bit, and I think we're on the process of that, so that's good.
Yeah. And Ash said thank you for the information. So yes, I thought Ash might be interested in this as well, because she's, I think she was involved last summer in a couple, kind of a couple discussions about this sort of thing. So it would be, yeah. If anyone's interested in contributing to this, it'd be great. So okay. So the next thing I wanted to get it. Well, I'll continue on. I have more things, and then I'll do the presentations and then the papers. So the first thing I want to talk about, we'll go back to the thing we were talking about with the Cognition Futures website. So this is the current website. It needs to be updated, and we have a couple talks that we need to put on, and it'd be nice if we had like it'd be nice if we had a stub specifically for this event. So I don't know. We don't have a menu. It's not really.
Yeah, I think I'm going to update it to basically reflect the changes I made to my personal website, because I like the way that GitHub lets you do that, or at least maybe a little more variation of that. But that definitely think there will need to be a hub for that specific, as you said. The cog site will be like kind of a big deal. Yeah.
Yeah, we definitely, and so that brings me to the where is this? I pulled up I don't know where we are with this. I don't have my papers up. Actually, I guess I can go back here and get the. Oh no, I can't. All right, let me go back this one. I think this will let me do it. Nope. Let me go back to the papers real quick. I don't know why it's not letting me go back into the thing, but come on. All right, I can't seem to get to my papers for some reason. I'm not really sure why, but all right. So why don't we just talk about this Cognition Futures thing? I was going to show this poster that I had created for the Cognition Futures session, but I don't know why it's not up. In any case, I have made this poster. It has the information about the meeting time and then the organizers. So Jesse and myself and Anson are organizing this, but anyone's welcome to join us and to come into the group and contribute. We're going to have people coming in from the CogSci conference. We're going to have people coming from outside of the CogSci conference, and I've created a Jitsi space. It's just like the Meet Jitsi Trajectories, so we'll use that space, and then we'll also maybe have some other support, like a Discord channel or something, or maybe the Slack channel that we can use for it. So that would be good, just to have like some conversation around it, and then having a meeting space that we can meet in and discuss things. And then, of course, we'll have to figure out the schedule for it. There's also a registration link, which is also linked from the document. And that registration link, people should, whether you're registered for the conference or not, you should use that registration link. It will allow you to get into us to get a list of people who are attending, so we can make sure that people are, maybe we'll create a mailing list even after, before the conference, to get people some information about, readings, the upcoming readings. So
yes,
yeah. So what do you need to get started, and then so yeah, that'll be good. And again, you don't have. I have 3, so you don't have to be like an attendee at the conference to join in. You can join in as just an interested participant. Now, that being said, I have 3 complimentary passes for CogSci. So I think Anson and Jesse and myself will get the complimentary passes, and they're just. I know that Jesse's been getting the emails. I don't know if Anson's been getting the emails, but in one of the emails, there is a link to the the instructions on how to claim your pass. So I think you just have to go into the thing and choose like, complimentary or something like that, and it lets you go in. And so that's something we want to do. But yeah, we definitely want to get a mix of people. I think just getting people from the broader community is going to be valuable here too.
Yeah, there's a lot of we could either do like a very little amount for this whole thing, or like there's a lot we could really do with this event. I honestly quite surprised that. I don't think it's going to be like a blockbuster per se, but I think it'd actually be really good for the lab and for Cognition Futures, but like I think there's a lot of fun things we can do. Like I really like the idea of getting the email follow-up list and maybe having for the lab's sake, finding ways to highlight some of our projects like in developmental AI or Metabrain stuff. I think there's a way to kind of artfully showcase that and give people a chance to do that. But it will be, I don't know if you want to update, like the Cognition Futures website is, kind of its own thing, but like if you want to update, if you want to coordinate anything with the lab itself or the main website or anything you want to do like in the logistics or administrative sense, I'm definitely game for that. And that's also like if anybody's particularly like, ooh, I want to think about that or brainstorm or help with that, even in just like how we can cross-pollinate this with other things going on in the lab or things that you might be interested in, you're welcome to bring that up anytime. But I think there's a lot of, I like the ideas that you have, Bradley, and I think there will be, that's something to look forward to. Like it's, in my mind, the concept of being something being 2 months away is like, it's pretty close. So, given everything else we have going on and that I have going on and Anson is going on, but that'll also be something I haven't. This is one thing. Like, if there's anything particular you want me to mention to Anson specifically, let me know because once he's settled in the UK, this would be, he and I will pretty much be in the same location, so we can have a lot of talk about it then and really flesh things out at that point too. Yeah. So that'll be less than 10 days from now. But, yeah.
Yeah, that would be great. I think run by some of the stuff with Anson, make sure that he's. I'd like to really see him give a nice, contribution. I don't know if we want to do like independent talks or if we want to have like a. If he has, like, maybe we could do, like, where we do the demonstration of the trajectories, if he could lead some of that and kind of give, or maybe, I don't know what his strength is really in, like, synthesis. So maybe we should focus on that. Because, I mean, I don't want to, like, force people to do something that they don't really know what they're doing. I want people to draw from their strengths. So that would be good if we could, like, find, like, maybe he could give, like, prepare some of the initial talk on it, just kind of like, maybe providing some examples or some slides about, things that, maybe the impetus for what a trajectory is, some of the things from the literature. I know he's read a ton of stuff from this area, so he probably has some good ideas of how to define basic terms. I think defining key terms should be at the beginning of it. And then we should move into, like, how do you put this together? And then the idea would be like, okay, we can create these trajectories from all this literature that you're reading. How do you do that? And, it's not like we have to... Yeah, it's going to be a challenge, kind of. But
I have created a second document now, which will be about this event.
Okay. Yeah.
I'll be sending that. I'll send out this document after the meeting. In the Slack for sure, and also the Anusha Critical Periods document. I I think I can just share that now. Actually, it's not. It needs a little bit of work, but just if people have ideas, you can start putting stuff in there. Yes. But yeah, it's time to start putting us into, yeah, I'll put this in the chat here. This is the critical periods one. Whoops. And again, this is like, whoop, this is still not working. To be fleshed out more. I'm gonna arrange the document quite a bit from I put different sections in there. Anybody who wants access to this, go ahead. But I might even start with the annotated bibliography on top, or have it a sense where you can just start filling out things, or and again, major names. We can have that can maybe be in the reference section somewhere or down there. But this is just a sheet of paper right now that has a couple of scribbles on it, but we can flesh this out into a more functional database, and using the everybody's looking at it now, I can tell, which is cool, but using the highlights, you can use, if I'm sure everybody's familiar with Google Doc, but you can use the columns on the left to kind of arrange things. And this is definitely, not finalized, but we can start fleshing this out, and creating some, critical periods. I'll put the name here. And we'll have it. I'm going to make one like this. I just made one like this for what we were talking about.
Oh, the
for the
trajectories,
future stuff. So, but this is the one I previously made. So, I'll share this too, or not. It's going to be basically blank paper, but just so you can know where to put stuff.
Right.
Okay. Anything else you want to talk about for that? These are all very good ideas, and I think that you wrote them down, and I wish I wrote more of them down in this document, but we can put them on the document.
Yeah, so I mean, I know Anusha's going to do an outline. We can fit that into this, too. We can put, this will be just kind of this, I don't know if it'll be unwieldy, but it'll definitely be the sort of the raw material for maybe other things we'll do.
And I think it might look a little bit, I have the vision in mind for how I want it to look, and it's just, after this meeting, I'll have more time to do it. But I just wanted to kind of throw it on there now. This will be the one for, I'll put this in the chat. What's it called? Discussion session? Affinity session? I don't know.
Yeah, something like that.
That'll be, for that later. There's nothing on it at all right now, so you don't have to look really. But just to have it there.
Yeah.
But yeah, the critical periods database one will just be generic organization of raw material, and then we can create specific reports or blog posts or actual things from it. So again, more after the meeting, but
yeah. Okay.
Anyway.
Yeah, that's great. So I'm gonna switch over here. I think I'm gonna just try to get to my papers here. I didn't bring them up like I usually do, but for some reason I have so many tabs here. Okay, so I've got this. Actually, yeah, let me show you the poster then. Let me share my screen. So I did want to share the poster here. This is the poster, Trajectories in Cognitive Science. So we have the date, the organizers, the location, the registration links. I made a little tiny CC, a tiny URL for that. Cognition Futures website, then the affiliates here, the conference and the lab. And then this is the thing we need here for this. What is it about? What is this about? So we need to have a short description of that. What is a... I know we've done this before for things, but to make this a very succinct description of the session to make it compelling to people. Okay, we can put that in here. And so the idea is to make this attractive to people, to make sure that they know that it's useful to them. Like, if you just say this is about this, we're going to do this thing about trajectories and cognitive science, and that's not really informative. We want to maybe make connections with the cognitives. If we go to the conference website and we look at the sessions, for example, what are the sessions that people were thinking about during that week? And if we know that, then we can maybe kind of figure out maybe who would be interested. So we could say, oh yeah, this group might be interested if you're doing history of science, or maybe you're doing some debate in cognitive science. That's something that would be of interest to you. So we can work on that copy, and then we can send this out before the session. We can publicize it on social media and so forth. And then we can get some people to come in and enroll or to register for it. Then we can maybe send out a newsletter or an email list, or advertise it on social media a bit and get people interested. So definitely we want to promote it before the session. Yeah, so that's good. And so more on that later. Okay, that's the papers. Let me get to the papers here.
No, that looked good. Thank you for putting that together.
Yeah.
There are specific. Could you put the link to that somewhere? If that's a.
Oh yeah, I should have done that.
I'll put that in the document that I'm making as well.
Let me grab this.
Calling that a flyer or something, maybe?
Yeah, it's a flyer. It's I guess a promotional flyer would be the name. Okay. Let me put it in the chat here. So that's the promotional flyer, the Google Doc there. Yeah.
Okay.
All right. Then we have our submissions for the week, and I don't think there's really much new here. The only thing, we're working on these two conference presentations this week. I don't think there's much to say about that, except that we're kind of in the home stretch on that. We have, there's this unsupervised reinforcement learning workshop. I don't think it's June 9th, so I don't think we're going to make that for any sort of submission. There's the NeuroIPS deadline is passed, but there are probably workshops coming up on that. There's this International Society for the Study of Information. That's going to be the 15th of June. That's an abstract. So that's like a 300 to 500 word abstract. And that's due June 15th. So for this thing, this is, I think, the information theory aspect. That's what they're playing up on this. I was thinking of submitting something on Gibsonian information. I'll just put the abstract in and see where that goes. I don't think there's anything else we need to talk about right now. I think we're the cognitive offloading conference that was submitted, that abstract that was in the Slack. That was a Slack discussion, and Angela and Jesse are also on that. I haven't heard back. I've heard back that they're organizing the session, but they said they'd let us know for sure what the acceptance status was by the 15th. So we'll hear back about that. So that's that. So I wanted to get into some of these things, these presentations. So this is the presentation for the Agent-Based Modeling Conference. This is Metabrain Models, Biologically Complex Agent-Based Models. So this is an agent-based approach, but it's this Metabrain Models approach. And I don't know how many of you have encountered this previously. We haven't talked about this in a while, but basically it's these layered models that we use that kind of resemble brains. The idea is that we have layers of with different representational sort of complexities or there's a difference in representation between the models, and they work together basically. So it starts out with this black box versus white box modeling. I think the slide was from the Philosopher's Web Cafe. It's the idea that you have this black box, white box, and gray box. So white boxes are based on first principles. Black boxes are models of the phenomenology, but you don't know what's inside. And then gray boxes are a mixture. And so there's that slide kind of going in, and then it kind of goes into this discussion of these, what Metabrain models are. You have basically these gray boxes where you have sensory input, you have low-level representation, high-level representation. So what that means is that you have something that isn't really representationally rich. So like a neural network is something that is highly connected, and it just generates information, but it doesn't have like any, there's very little representational complexity or richness there. Different nodes don't have different identities. They're just kind of like exchanging information, and things emerge out. You don't necessarily know how it works. And then high-level representation is like a symbolic model where everything is specified, and you have, it's maybe generative, but you know kind of how it works. And so those things can be coupled in a way that's informative. So this is showing that you're getting sensory input. Then there's communication between the two levels of representation. So representation free and representation rich. Then we talked about Bradenburg vehicles, which are simple models, and kind of going through the behaviors that they generate. And then some of the things we've done on developmental Bradenburg vehicles, where you have these, you can even combine different types of, you can have like these unspecified nodes, or you can have these kernels that are of higher representational value. And then this is the sort of the second, so this is like the evolution, this is early development, this is later development. And then this is a CGS classification, so I mentioned that here. Getting into a couple slides from the CGS talks, where this discusses contextual geometric structure. So this is where you have the space within a space. It's sort of a sensory classification space. So these are like input sensory inputs, and then your phenomena is within this space, and it's classified according to some membership function, which is different than a probabilistic function. I will talk about that in a little bit, but and so you have these cultures. If you have a bunch of these classifiers in a population, and there's overlap in the cultures, and it gives you a lot of contextual information. Here's another representation of this. So it's a very detailed representation of natural phenomena. And then you can actually build these epistemological representations. So you have a conceptual kernel and a sensory kernel, where you can map between them, sort of a reentrant map. So there's sort of layers within layers here. So our CGS layer is that top layer, the neural network is the bottom layer, and then within that top layer we have these sorts of different layers of representation. And then you can create a cultural representational continuum using this type of approach. So this is an idea for one, using sampling of the color scheme. So you have a color space that you're sampling different colors, and you're representing it in one of these contextual spaces, and it's giving you this, the range here is like a physical range, but there's certain things within the physical range where you're sampling and you're putting in these hashes. So it isn't just it's giving you a full range of possible points of reference, and you're picking like a subset of them. So then I get into this Ashby, Simon, and Schelling, which is, I think they took this from one of the agent-based modeling talks that I gave last summer. So this kind of gets into the different aspects of agent-based modeling. So Ashby argued that systems are too heterogeneous and information-laden for reductionist approaches. Simon said that hierarchy is a universal feature of complex systems. And Schelling said that segregation can occur from a random initial condition. So these are all statements about what an agent-based model can do. And so we've seen in these examples up here that you have this representation-free and representational-rich set of representations or a set of things working together. Now, if you put that in the context of an ABM, what does that look like? So the first thing we'll talk about is the Schelling segregation model, which is this Micro Motives and Macro Behaviors book. That's where it was introduced. And the idea is if you have two groups, red and blue, and they have a degree of preference for homophily, in other words, having a neighbor in the same group, and that's all they're operating on, you'll have this complex pattern of behaviors in the array. And finally, eventually you'll go from like a well-sorted matrix to something where you have patches of red and patches of blue. So the cells will change their place of residence to be near a cell with the same color. But most importantly, during the sorting process, you get tipping points where you go from random assortments of different colors in regions to these segregated patches. So it doesn't just it happens gradually, but you get these tipping points where you can really start to see the emergence of these macro behaviors. And so what would that look like in a Metabrain model? We assume in the segregation model that there's just a simple rule. And the rule is that, we have this preference rule. That's it. With a Metabrain model, we could be a little bit more specific. We can put this on the grid, and each agent would have 3 layers. You'd have cellular automata, which is the bottom layer, which is sensing the social environment, which is basically what these automata are doing already. But then you would have a neural network, which maybe makes sense of the world, and a Bayesian model, which models beliefs. So you can replicate this segregation model, or you can extend the segregation model to something that shows alternate behaviors based on these different layers. And you can think about this as like a model for human behavior or for animal behavior, where you're getting this simple preference. And the idea was that these simple preferences drive behaviors, these macro behaviors. But in this case, you can see that maybe it's not. Maybe if you add other layers, you can get maybe different types of outcomes. Or we can understand maybe that that's not always the way, that there are other options. So when in cases where you want to reduce segregation in a residential community, you might be able to use a model like this to sort of figure out how that might go about doing that. Introduce things that are not just like simple signals. But of course, you can also understand, what's going on, because a lot of times this model doesn't map very well to human and animal behaviors. And so why is that? And so a lot of times we'll use these models as sort of shorthand for very, easy to observe things. But sometimes the processes are much, more complicated than just saying, well, there's a simple preference. And so we can understand now these as well. This is just one configuration. You can change the configurations, but this is just an example. Something related to this is the Ethnocentrism Game, which is from Mark Granovetter. This is a threshold of collective behavior model he published in 1978, and it's very much related to the segregation model in the sense that you're getting these different ethnic groups, as they call them, and they're evolving, and you're getting them, they form. But critically, you have this transition point, which is a critical point, another critical point. And so you can see that, you can have a similar thing here, where in ethnocentrism you have this sort of simple preference, but you also have this sort of ethnic identity, and you have this sort of cultural aspect to it as well. So, the idea is that you have different ethnicities, and they want to, tend to be together. They tend to exhibit ethnocentrism, which is where they believe that their beliefs are the best, their ethnicity is the best. And so it's similar to the segregation model. But you can also model this in a different way from the segregation model. You can use a dual inheritance approach. So in this case, you're using a genetic algorithm as sort of the sensory layer here, which is interacting with this grid, and a neural network. So the genetic algorithm would be kind of like the generation of these, of diversity of groups, and then neural network would be something that's allowing you, on top of the genetic algorithm to sense your location in this space. And then you're interacting with a second inheritance layer, which is where you have a neural network. It may be like a contextual geometric structure. And this allows you to sort of develop, ethnic diversity or ethnic sort of beliefs. And then, you have these agents that interact. So they're interacting at this bottom level, and they're exchanging information. And these inheritance models are, they don't necessarily, they can be independent, they can work together. And then so you also have, then moving away from sort of social phenomena, you have chemical morphogenesis, which we typically model as reaction diffusion. And so this is an example of reaction diffusion where you have particles that kinetically diffused across the space. And the idea is that there are these gradients which can collide, and then where they collide, they form these boundaries. And so they have these very sharp boundaries at the boundary of two gradients, and this is how you get patterns in like a chemical soup, or even in like animal coats. If you look at like a zebra or something where you have stripes, the idea is that you have this morphogenetic process where you get these different molecules interacting, and they form these gradients, and then they form these sharp boundaries. So one way you can actually model this is using conceptual functions, not necessarily model specific, but we want to use something we're calling morphogenetic agents. And in this language of sort of layered models or metabrain models, you have this simple sort of set of layers where you have pattern production at the bottom, which is interacting with this space. And then you have perception, and then you have pattern recognition. So this is a little bit odd way to view this, because we think about this as like being a purely chemical process. But the idea is that these patterns are also perceptual, in the sense that, like, and you'll see what I mean, these patterns are perceptual in that they form, and then they have to be interpreted by like some other organism to be, of some sort of, and then they feed back to the other organism. You'll see what I mean, to be perpetuated. So there's this model, and this is the model I'm talking about. So this is sort of, you have a pattern producer here, and a pattern emitter, and then a pattern recognizer. And these are two, we'll call them, we don't want to call them organisms, we'll call them agents. And the idea is that these pattern emitters will emit a pattern. They'll do some sort of pattern formation in their phenotype, and then the pattern recognizers will sort of figure out what the pattern is. So they don't know a priori what the pattern is going to be, but if they can recognize the pattern, maybe say from a background, they can maybe predate upon this agent, or they can identify the agent against a background. And so this is where the pattern is like has some meaning to it. So this is an example where this pattern emitter is creating this stripe pattern, and the pattern recognizer, is it a checkerboard? No. And then they keep emitting that same pattern. Finally, the pattern recognizer figures out what the pattern is, and then now this pattern has some meaning to it. It's recognized. And so this is the relationship between morphogenesis and perception. And you have this, you can actually combine these two, so a single agent can have both morphogenesis and perception combined, so they can emit patterns but also recognize patterns in other agents. And then there's this link between these spatially restricted shapes and attentional mechanisms that can evolve in the same agent. And then you have this synchronization and coordination across layers. So we've been talking about these layers. What does that mean in terms of coordinating between them? Because I've shown these arrows, but I don't really tell you what that is. So there are actually two ways this can be done. In one instance, you have this something called a genotype to phenotype agent, where you have these coordinated levels that represent different levels of sort of organization in an agent or an organism. So you can go from like something like gene expression to like maybe a tissue function to maybe some sort of collective or some sort of behavior, and then some sort of collective behavior across agents. And these things are all sort of within the same agent. There's sort of I wouldn't say a causality, but one level informs another level. So you have that sort of integration. So this is vertical integration. Information passed in one direction from one layer to another. The top layers constrain the lower layers. So the gene expression informs layers above it, but then these layers here constrain what happens below. So the behaviors that are exhibited can constrain, say, like gene expression, but gene expression informs the behavior, and there's this implicit feedback loop that forms within these layers. Then there's also another type of integration, which is isometric integration. So in this case, I'm just showing one of these multi-layer models that I showed previously, and these are, mathematical constructs or computational constructs. So this is a little bit different than, say, like a physiological analogy. This is where you have isometric integration. And that's where information is exchanged in geometrically specific ways. So you can see that here you just have these little bars. It's like a Neapolitan ice cream where you have like 3 layers and then they're interacting. That's not very interesting from a geometric point of view, but if you had like I showed you at the beginning, where you have this curvature, you have other types of things. We know that, for example, the neocortex in the human brain is highly folded, so those folds have some functional benefit or some functional aspect to them. And so you can fold these layers together in different ways, and it actually helps in the exchange of information and coordination. Another method here is looking at things like corticostriatal thalamocortical loops. It's a mouthful, but basically it's the idea that you have these pathways in the brain that go from sensory motor cortex, say, through the putamen, and then into the back into the thalamus, and then back up as a feedback into the cortex. And so you have these loops. They're based on, we don't really think of these as layers per se, but in a model you would abstract it as a series of layers. And of course these layers have different levels of representation. So like the putamen here represents information in a certain way. The thalamus is more of a distribution network, but it also represents information in another way. And then the cortex represents information at a higher level of representation. And so all these things kind of work together in this way. So in brain networks, they're organized in a hierarchical but distributed fashion. So they have both attributes of hierarchy and distributed network. In these cases, feedback loops predominate, and functional nodes are spread out across multiple centers. So your different layers are interacting in different ways, and that's how they do in the brain, so that's what we're trying to approximate. You also have this idea of feedback in the Evergood Regulator theorem. So this is an idea from cybernetics, where you can take this boxes and arrows generalization. We have an internal model, which is an approximation of the environment. We have this empirical input, which is like an integrator of what you observe in the environment. And then you have a copy of the internal model that attempts to match the environment. And this, we can call it an efference copy, although it's not technically correct. It can actually feed back to this, internal model. So it's a copy, but it's a qualitatively different aspect of this internal model, and it can feed back to this approximation of the environment. So it gives you this ability to, achieve what they call good regulation in cybernetics. Finally, there's this idea of hierarchical predictive processing, which is where you use this sort of Bayesian approach to look at like how things are predicted in the brain. And so in predictive processing, they ask the question, what is the probability of a sensory signal? And you have feedback between error units, which are orange here, and state units, which are blue. And this is another example of this. It's just a little bit more formal, but they actually have measured this in terms of prediction error and put this into a Bayesian framework where there's a difference between the prediction and the sensory and the prediction units, and then the difference moves the posterior of this distribution more towards the actual signal. So finally, can we represent layers in a more topologically and biologically realistic manner? So I said before that these layers are kind of like Neapolitan ice cream, or they're kind of like just generic bars, layers. But can we model this in a more sort of topologically and maybe biologically realistic manner? And indeed we can. So we've done this work, of course, with the Bradenburg vehicles. We've done this work with morphogenesis and metamorphosis. So in the case of morphogenesis, we can take these innate components of the vehicles. We can build a developmental Bradenburg vehicle where you have innate components, which are cells, and we can change the size of course, of development and arrange them into rings and things like that, and then finally integrate them into a body that can behave in the environment. So we can actually modify the shape and development, and then that affects its behavior. The typical Bradenburg vehicle, of course, will just kind of behave with respect to the stimulus, but in these more complex morphological forms, we may be able to do more interesting things. And of course, you can just develop these vehicles wholesale. You can take a simple triploblastic model, which is where you have 3 layers of tissue, and you can distort this and form agents, embodied agents, that have different properties. So you can have a neural network as one layer. You can have the vehicle body as another layer. And you have these sensors and effectors as a third layer. And if we go back to the original slides, we can see that we had 3 layers where one had a very low level of representation and another with a higher level of representation. And in this case, we see that in development, this neural network differentiates into 2 different layers and with 2 different representational capacities, the CGS kernel and the neural network surrounding it. And so we can time the emergence of these layers in development and build certain shapes so that they're sort of close to one part of the organism or another part of the agent, and that might have an effect on the information processing and how they behave. So thanks for your attention. So that's what I had on that.
I like this, and this is also for people who aren't familiar with some of the things that's been going on in the lab for a while, there's a lot of things that are touched upon there. I think it's a really cool way to look at what we've been doing in the lab in general. Metabrains have been something that, that was kind of the first project that I worked on really, was Metabrains and developmental Bradenburg vehicles, and kind of seeing the evolution that's come from that time, and even incorporating some things from our more recent discussions in there. It's exciting to see that. I like that, and I think I know currently, I think everybody in the lab right now, we don't have a major focus on some of those applications in what we're talking about mostly in the weekly meetings here. But if anybody seeing this from outside the lab, or I think Akshara left. Right?
Yeah, she had to go.
I think she was kind of doing some of the reinforcement learning stuff on one of those things a long time ago.
She was interested in agent-based models of different, she does a lot of stuff with optics or with vision and optical.
You also get into the PhD program about that?
Yeah, she did.
I didn't know if she wanted to say that, or I was oh, maybe it wasn't her because she didn't talk.
Oh no, she actually, and I put an announcement in one of the Slack channels. I don't know if I did or not about.
I was going to mention it directly, but I was like, I don't want to mistake that. But yeah. So congratulations to her, but also there's I think that project. I think this talk will actually be really good. It's a very interesting concept, and it brings together a lot of things we've been talking about since my whole time here, which is very cool. And as a side note, this is more of a tangent because of agent-based modeling, but Rachel, the person who I mentioned, is at that like Culture Institute who does work with agent-based modeling. Mm-hmm. It does remind me of her again in the sense of maybe having her come to talk to a lot about agent-based related stuff, especially when you're talking about like the agent-based models for like segregation and ethnocentrism. Yeah. Those seem like particularly, you know, I don't know how to really tie that in with our lab right now, but just kind of a note on that again. Look, I think she'd have a lot to say about that, or at least be someone who's using that in the industry or like pseudo academic industry version of that.
Yeah.
But outside of that, yeah, this would be a really nice setup. I think it could be kind of a feature, like a condensed version or reference of this talk could be something we mentioned at the CogSci event too. Just like, hey, you know, here's one way of looking at, you know, an implementational sense of looking at trajectories in cognitive science or modeling them. I think this. I'll put that in the document now, actually, also.
Right. Yeah.
And this is for which? This is for agent-based modeling, and what was the conference? Is this the social science?
Inverse Generative Social Science workshop.
Okay.
It should be in the submissions document. I think it's...
Yeah.
Yeah.
Okay, cool. No, that was really good, and thank you for, like... I know this is kind of a bit of a conglomerate of things we talked about in the past, but, I mean, I think it flows pretty well.
Yeah, I'll have to rehearse it a couple times before I give it, because it's just kind of like pulling things from different places, so it's got to be... I mean, I just have to think about, like, when it's presented, the flow, but I think it should be all right. But yeah, so yeah, that should be good. So I wanted to talk about another thing, and this is just food for thought, and then I'll maybe do a paper or two. But the second thing I wanted to talk about was this thing. I've been trying to do this for a while, and I haven't really been able to figure out how to present it. But this is just food for thought, and this topic is intransitivity. So this is something that I might do a longer talk on this summer, but. So what is intransitivity? I'll get into this. So one idea of intransitivity is this book, I Am a Strange Loop by Douglas Hofstadter. And this is a classic book in cognitive science. This is where he talks about recursion and, like, you know, different things where he's kind of musing on, you know, how we think about recursive systems, and we think about things in terms of transitivity. In other words, A is greater than B, B is greater than C, therefore A is greater than C. But a lot of things in the world aren't really like that. So that's one of the things he kind of explores in this book. Something else from, this is John Bjorn Nelson, who's on Twitter as Generativist. This was a while back, he posted this, but he says, it's a bit stretched, but imagine gradient ascent on some Escher stairs. So everyone knows a gradient ascent is where you're trying to find the maximum, or gradient descent, or you're trying to find the global minimum. So imagine gradient ascent on some Escher stairs. Without the rich context, you'll imagine yourself making continual progress, but mostly you're just going around in circles. So if you look at the Escher stairs, you see that they're a little blurry, but I think everyone's familiar at least with this idea that you go up the stairs, you keep going, following the stairs, but then because of the optical illusion here, you go down the stairs. So you start here, you go up, you're ascending the stairs, and then you get to this point, you know, you get back here, all of a sudden you're at the same place. It's because part of these stairs ascend and part of these stairs descend. But when you're on the stairs walking, you never notice the difference. So you always end up in the same place. And it's a little bit of a strange idea, like, why would that be? I mean, we know the visual illusion And Escher had some really interesting ideas about visual illusions and how to model. I mean, that was his whole career, was like modeling these sort of systems that had a visual illusion that, you know, kind of made you think one thing, but you were doing something else. So this is this idea of recursion. But if you were to put this in the context of like gradient descent or gradient descent, it's really interesting. I like that. But this has been applied in a lot of areas of science. In fact, we have the rock, paper, scissors game, which is something that is used in behavioral ecology a lot to look at mating strategies. So in side blotch lizards, for example, and even in molecular systems where you have population dynamics of genes and other things. So you have this, I think this is from bioengineering and this is from behavioral ecology. There's this Quantum magazine article, Biodiversity May Thrive Through Games of Rock, Paper, Scissors. And the thing about rock, paper, scissors is that it's a game where it's intransitive. So it's not transitive. So the idea is that, like I said before, a transitive game, you would have scissors, paper, and rock, and there'd be a clear suboptimal strategy. So for example, you would think maybe, for example, that scissors and paper beat rock. So one of these strategies would have to be at the bottom. Like A is greater than B, B is greater than C, A is greater than C. C is at the bottom of that. Now, in rock, paper, scissors, that's not the case. Something always beats something else. So scissors beats paper, paper beats rock, rock beats scissors. So people implement these strategies at random, and that's actually better than having a pure strategy where you do the same thing every time you play. And so by virtue of being intransitive and by virtue of it not being a pure strategy, you know, it just keeps, there's a clear sort of, there's a clear sort of variational aspect to this that is attractive to like theoretical biology and behavioral ecology, in that mainly that you don't have this sort of, you never really reach an equilibrium. So they've had like tournaments online of rock, paper, scissors where they've built programs that have tried to play rock, paper, scissors and find optimal strategies or to play them again and again. There's even a version of this called rock, paper, scissors, lizard, Spock, which is like 5 states instead of 3, and it's the same idea of intransitivity. It's just more complex. There's this paper here in Journal of Theoretical Biology, Species Coexistence, Intransitivity, and Topological Variation in Competitive Tournaments. And this kind of goes over this competitive intransitivity. So this occurs when a species' competitive abilities cannot be listed in a strict hierarchy, but rather in the form of competitive loops. And so indices are useful for summarizing these in communities, but with most as with the case of most indices, a great deal of information is compressed into a single number. And so they kind of get into like a continuous analytical model that they use to understand a little bit more about these dynamics. We show that although intransitivity indices are good at capturing broad patterns of coexistence, communities with different levels of intransitivity can have equal coexistence, and communities with equal intransitivity can have differential coexistence. So, you know, this is, you have to read the paper to know exactly what that means, but people have been working on this problem for a while. But there's transitivity and intransitivity in a lot of areas of science, and I'm going to go through some of them here. So there's transitivity and perceptual simultaneity. And this is a special issue of Frontiers in Integrative Neuroscience on interval timing. I think we talked about interval timing a few weeks ago. But this opinion article is called Why the Transitivity of Perceptual Simultaneity Should Be Taken Seriously. And so this is where you have, this is perceptual simultaneity. So the argument here is a relation is transitive if and only if, from the fact that A has a relation to B and B has a relation to C, it necessarily follows that A also has a relation to C, as I mentioned before. As a relation fulfilling this requirement, consider simultaneity understood as 2 events occurring at the same time and only at the same time. Thus, this is not the case of mere partial temporal overlap. So this is where you have 2 events coming in at the same time. They might be in different modalities. Like you might see something and you might feel something. You might hear something at the same time. So, you know, when you have something like thunder and lightning, those are not simultaneous. There's no simultaneity there. But if you have something like you're falling and you hit a rock or you hit a surface, that's pretty much simultaneous. So that's the idea. So the idea is if A and B share all the same temporal properties and B and C share them too, then it is impossible for A and C not to share them too. So there's this transitivity of, you know, this is almost like associative learning, where you're associating a couple of things, like 3 things instead of 2 things. You're associating A, B, and C, and you're making a comparison between A and B and C. And then you have to make this loop where you say A, B, and C are sort of organized in a hierarchy or that they have relative properties. And so this is the idea. On the other hand, to be non-simultaneous or asynchronous is not a transitive relation because A and C can be simultaneous, although both of them are non-simultaneous with B. So when you start getting into like thunder and lightning, you start getting into this situation where they're maybe non-transitive. And so the direct comparison in time can't be made. And so, you know, you have that going on. So they talk about perceptual simultaneity, and they talk about comparing things, and you can have intransitivity that emerges from things that aren't simultaneous. And so they cite this paper, Kelly, 2005, The Puzzle of Temporal Experience, and that's important in understanding this. Going back to the contextual geometric structures work, our soft or fuzzy classifications that we use for these are actually good examples of classification systems that don't require transitivity. So we don't require this relationship. This is non-transitive. Or, you know, and then it has relationships to both symmetry and distributivity. So like in a typical sort of classical set theory example, things would be transitive, symmetrical, and distributive all at the same time. Those are the 3 requirements. But in the case of fuzzy classification, you don't need these. And so that comes to an advantage when you're dealing with these things that we just talked about. And, you know, it's important maybe in regulation as well. So we have these relationships. We have transitive relationships. We have intransitive relationships. So there, you notice the arrows are a little bit different here. And we can actually look at this in a cybernetics framework. So we can look at like transitive relationships as being this sort of feed-forward relationship, and intransitive relationships as being this feedback relationship, where you have, in the transitive case, you have A contributing to B and then B contributing to C, whereas an intransitive situation where you have feedback, A contributes to B, B contributes back to A, and then B also contributes to C. And then that changes the quantities of these 3 things. So this actually, you know, you can extract the transitivity from the feed-forward case, but in the feedback case, because B is contributing to both A and C, it changes the relationship. And you can think of cases where you have feedback where that might be the case. You also have cases where you have transitivity and intransitivity in these sort of networks where A is contributing to both B and C, and then C is contributing to B. That's a transitive case. So this is like more of like when you have networks of, you know, like this is, I guess this is feedback, but this is a case where it's transitive. And then intransitive is where you have loops, feedback loops, but they're actually much more complex and they're doing a lot of stuff. I tested this, and I think this works. So the idea is that you can have feedback networks that are both transitive and intransitive, depending on how they're structured. And so then you have something called probabilistic intransitivity, which is something that they use something called non-transitive dice to study. So the first model system is this rock, paper, scissors model. Then they also use, in probabilistic terms, non-transitive dice, which are different from classical dice. And, you know, you can look up more about non-transitive dice. I think Microsoft Research has been doing work on non-transitive dice for computing applications. So it's not like it's just a curiosity. But there's this probabilistic intransitivity. So they're using these things called intransitive dice. This is from the Wikipedia page, where they give like this matrix of of this payoff matrix for choosing different sides of the die or different die, and gives you a payoff. So then there's this Bayesian intransitivity. So, we think about the difference between cybernetics, probabilistic models, and Bayesian models. Like, I think we had we talked about that debate several weeks ago, but this is so I've talked about probabilistic intransitivity, cybernetic intransitivity, and now Bayesian intransitivity. And this paper is kind of a thick haul here, but I just gave the abstract and the summary evidence. So the idea is that it is known that evidential support, the Bayesian definition of this notion, is intransitive. According to some, however, the Bayesian definition is too weak to be materially adequate. So they investigate whether evidential support, we talked about that in the prior talk, if you observe something and what's the prior, does it match up, does it support that? Evidential support is transitive on some plausible probabilistic strengthening of that definition. It is shown that the answer is negative. And so even under conditions in which the Bayesian notion is transitive, the most plausible candidate strengthenings are not, which means that you can, this Bayesian definition is intransitive, but so is the probabilistic correction to this. So, so it cannot be excluded that evidential support properly construed as transitive, at least that the relation is strong evidential support for is transitive. So this is, this goes on. This is very mathematical, this paper. So they work out the symbolic logic of it. But I think the takeaway from this is that you have these different ways of looking at intransitivity, in that we think of the world generally as transitive, I think, a lot of times, and yet there's a lot of support that, like, a lot of cognition, a lot of behavior is actually intransitive. So this is something to think about for maybe future, maybe it'll inspire someone to think about some of this stuff, and maybe we'll come up with something on this. I just wanted to put that out there as as something to kind of think about. Finally, I just wanted to talk maybe about one or two papers before we go.
No, that was good. I like the talk, and that'll be something that kind of sticks around the back of your mind for a bit.
Yeah.
I think that I even see some ties in developmental AI and other just what that's a layer of analysis that I haven't used that much, but there's obviously a lot of overlap in it. It kind of reminds me of some of our I'm glad to keep referencing the Bayesian versus cybernetics debate or whatever.
Yeah.
I think that's going to be a really interesting conceptual. If I had, maybe I'll start making a little bit of a note document about this, but just key concepts of discussion within the lab and kind of our general research, that's one of them, and the way the way it's been incorporated in that was definitely noteworthy.
Yeah. So I definitely encourage you to kind of let it roll around the back of your mind and think about it, and it should be, there might be something to come up of that. So finally, I wanted to review two papers before we go, just quickly, and I probably won't do these justice, but I think this first one I ran across this week, and some thinking about some of the stuff that we were doing with with Stefan several years ago now on developmental Bradenberg vehicles. One of the problems he had was that he wanted to evolve networks. So we wanted to evolve them from a small size to a fairly large size over time, right? And he was using a genetic algorithm to do this. The problem is that it's very computationally intensive to generate these networks of any size. And so you can do this in a number of ways, but it's still going to be pretty expensive to do this and get the connectivity matrices and all that. So this paper is interesting because it's both from 2008, which is a while back now, but it actually gives us some information in this area as to how, and this is to, I think, the developmental Bradenberg vehicle specifically, how to view these things in terms of like, can we understand them, and how can we, how can we think about like, how they build. So Eduardo Izquierdo is actually involved in the OpenWorm project, and Randy Beer is a very well accomplished. He's at Indiana University. He's very well accomplished in like agents and CogSci. So is Inman Harvey. So this is a good all-star cast here. So this article extends previous work on evolving learning without synaptic plasticity for discrete tasks to continuous tasks. Continuous time recurrent neural networks without synaptic plasticity are artificially evolved on an associative learning task. The task consists in associating paired stimuli, temperature and food. The temperature to be associated can either be drawn out from a discrete set or allowed to range over a continuum of values. We address two questions. The first is, can the learning without synaptic plasticity approach be extended to continuous tasks? And if so, how does learning without synaptic plasticity work in the evolved circuits? Analysis of the most successful circuits to learn discrete stimuli reveal finite state machine like internal dynamics. So a finite state machine is where you have a series of discrete states and you have these transitions between them. So that's kind of like a boxes and arrows diagram. And the idea is you have these states that the system moves between the states continuously. So like you might have like a light switch is on and off. So you might have an on node and an off node, and something that goes from off to on and something that goes from on to off, and then two arcs that like allow you to go from on to on and off to off. So it's like this that's where you just maintain yourself in the same state. So at every time period you have to make some sort of transition in the network, and so you either stay in the same state or you move to a different state. So that's a different way of looking at like a light switch. We think of it as maybe a zero order dynamical system or a zero order cybernetic system. It's just the simple FSM. And so the FSM is actually a good way to understand the system, because you know that the network is producing outputs, right? You have this neural network that's producing outputs. The question is, can you always classify those outputs into a discrete state or not? And I know that Eduardo has worked on some of this with the C. elegans, some of the C. elegans sensory motor networks. So there's some subnetworks in the C. elegans connectome that provide a way to understand this. And you can use finite state machines to understand the output of the network. So if you have some input, you're bringing in information and you're putting out a sensory motor output. Can you always classify it, or can you understand it? However, when the task is modified to require learning stimuli on the full continuum range, so they're modifying the task to be more complex and to have learning stimuli across time, it is not possible to extract an FSM from the internal dynamics. In this case, a continuous state machine is extracted instead. So this is going back to thinking about the outputs of the network and whether we can really understand them, and then what do we need to know to understand them? What kind of tools do we need? So I think this is really interesting from the perspective of these evolving neural networks. We had trouble kind of representing their connectivity matrix, but also in terms of what kind of behaviors are they producing. And I think that I'd like to really pick up again on the developmental Bradenberg vehicles. I know that Stefan was talking about open sourcing it, but we haven't really gotten around because we're just always busy. Everyone's busy. And we have to really kind of put an effort into it. But I think maybe if we define some tasks that people can do to maybe advance this a little bit more, we can get, make some progress. So this is a good paper. It's a classic paper. I think we should, in the stuff that we're doing on the continual learning that we've got, that we've submitted to from the EI workshop, I think this is a good paper to cite and to follow up on. But we'll talk more about that maybe later. The second thing I wanted to talk about was this paper by Andrew Wilson. This is interface theory versus Gibson, an ontological defense of the ecological approach.
Ooh.
And this is, yeah, I know Jesse would be really excited about this, but
Yeah, I feel like she was the answer too.
yeah. So interface theory, which is, I think, Don Hoffman, who's doing this stuff with, maybe I'm wrong on this, but like with VR and like, understanding the world. So like the idea that the world, that you're simulating large parts of the world, that what you're interacting with isn't really like there. There's an interface layer. And this isn't like HCI interface type things. This is like, just that the world, there's an interface between you and the world. So interface theory is the hypothesis that inferential representational theories of perception entail that fitness, not truth, dictates the evolution of perceptual systems. So there's this fitness versus truth. Truth being like the thing we always talk about in Bayesian models where you're like verifying things empirically, but actually it's fitness. And that fitness is there's an intermediate layer, which is this interface.
Yeah, did they say what fitness is?
Oh, well, probably later. They show with simulations that veridical perceptual mappings, ones that preserve at least some of the structure of the world. So this is where you have, like if you're looking at a natural scene, there's structure in it, there's like a skyline, there's like, trees, there's an up and a down and all that, are routinely outcompeted by non-veridical interfaces, one that make no attempt to preserve that structure. So this is going into like representations, like, things that are like blobs or things that are really abstract. And so there's this competition between veridical mappings and non-veridical mappings. And what they're saying is that the non-veridical mappings or the non-veridical interfaces outcompete or are more fit than the veridical mappings. And they don't really, they probably do get into, I'd probably go back to this original paper to know what they mean by fitness, how they really kind of determine that. They therefore take particular aim at the direct perception, ecological approach to perception. And this is from Michael Turvey and Gibson and other people, and work to show that such a system, even if technically an option, would never be selected for by evolution. So this is an evolutionary approach where they're using, people have different ways of looking at fitness. I think in this case it's like fitness, whether it's like, I don't know if they're using agents or what, but there's a definite way to sort of, they're basically determining the fitness of these different representations, maybe whether it allows the organism to do things in the environment or not. This commentary defends the ecological approach from this novel existential attack by showing that the ecological hypothesis is so different in kind to the inferential, representational view of perception that it simply falls outside the scope of interface theory's critiques. He really does have a take on this. Ecological psychology remains a viable scientific endeavor. So there is defending it from this line of inquiry. This analysis will show that far from being a radical new approach to perception, interface theory is simply a clear and elegant formalization of mainstream representational psychology, and any implication interface theory may have belongs solely to that branch of science. So he's saying basically stay the hell out of ecological psychology or whatever. So this is supposedly a radical take on the nature of perceptual experience in the form of their interface theory. So this is really it kind of goes through this. And this is kind of like one of these cognitive science debates that we see in the CogSci journals. I don't think this is in CogSci journal, but they just kind of get into the differences. I would go back to this original paper by Hoffman in 2015, this one here, HS&P, and then kind of, figure out what they mean by fitness, because it's, that's the devil is in the details sometimes on that. And then one theory of perception that seems to immediately lose in this scenario is James Gibson's direct perception ecological approach. Gibson rejected the need for internal mental representations performing information processing. So this is where they differ. In interface theory, there's a very strong role for internal mental representations. It's the interface between the world and the agent. In ecological psychology, everything's integrated. So you're just taking in things from the environment. And this is really the distinction here. And so if H, S, and P are right, and evolution will always favor non-veridical perceptual systems over any kind of veridical ones, then evolution will never produce a Gibsonian organism, and the ecological approach is therefore dead on arrival. But, of course, we know that, like, that's probably, I mean, you can demonstrate a lot of aspects of the ecological approach. So, I mean, you know, you have, this is a novel challenge to the ecological approach. Most critiques focus on the limits of what information can specify, and therefore what behaviors it can and cannot support, like catching a fly ball versus imagining catching a fly ball. This is an Andy Clark and Toribio argument from '94. Interface theory then claims that evolution will never produce an ecological perceptual system of any kind, that only a representational system can support perception. This paper defends Gibson and the ecological approach from the formalized objections raised by HS and P in order to demonstrate that direct perception remains a viable competitor. So he kind of goes through here and defends ecological perception from this. And so it's very, I would definitely follow up on this. This is something that Anson should probably read, definitely. And I'll put the link in the chat here.
Yeah, I was going to ask that.
All right. And Angela had to leave. Thank you for attending, and Ash as well. So, yeah, that's all I had. Any comments before we go?
No, I look forward to like having time to read papers and do stuff again and work with the lab. So, I don't know if I don't have any scheduled meetings with Erin or Angela or Anusha specifically right now, or you. But if anybody has any specific time, like, hey, Jesse, could I talk to you about whatever for an hour at this time? Like, I would encourage, outside of like, I have something at 2:30 today, but outside of that time, like if anybody wants to have a specific meeting about things, I will be available and focusing on. Like this is kind of the first time I have like a big open chunk of time, in maybe like 2 to 3 weeks, really. So I'm looking forward to doing that. But outside of like that, I like the papers. I like what we're talking about. And again, thanks for kind of carrying a lot of. So I appreciate that. But I look forward to kind of getting up to full speed again. And like outside of that, just a reminder, like I know Krishna wasn't here today, but again, really glad for him. Akshara is doing kind of the PhD program. It'll be good to connect with Stefan again about the brain rig vehicle stuff. There's a lot of things. This is a really interesting meeting for stepping away from our recent focus on deadline stuff and looking at the Metabrain project and the developmental brain rig vehicle component to things, and some things about what we could be focusing on next, because there's kind of the Cognition future stuff is honestly taken off a bit more than I expected it to. There's a lot that's going on with it, and I get a little bit wary because like I don't want that, or even like the ethics and society team to like dominate the lab too much. Like, there's a lot that's going on, so I think this was good for having a perspective on that front. And ideally, in a lab manager sense, there are a few more things I'd like to kind of flesh out. And like you said, I really definitely strongly agree with like creating some tangible, concrete tasks for either new people or like stuff to mention about like adjacent to either the ABM conference itself or Metabrain stuff, or for CogSci. Like, I think CogSci the discussion group can also. I don't think we're going to be using it as like a big promotional event by any means, but I think it would be a nice goal to have maybe even more fleshed out versions of like those project cards or whatever else, and having some specific, like, we're looking for someone to do XYZ with developmental brain vehicles or Metabrain models, or we have an open task to look at this, that, or the other thing. And a lot of those things came up today in these talks. So that's kind of my closing thought about everything.
Okay.
But this is all very good stuff.
Yeah. Anusha, did you have anything to add before we go, or? Okay. Well, thanks. Well, thank you for attending, and we'll meet up on Slack. And Jesse, we can touch base on Slack today and tomorrow if you have anything updates to give, or I know you like to give updates in Slack. It's pretty. I don't really know if I want to meet.
Oh yeah, I don't have anything like, hey, I need to talk to you extensively about this. I think that might be more so for some of the other people in the lab to focus on stuff to flesh out.
Yeah.
But I don't have anything I need to meet with you with. But there's definitely going to be. I think there'll be an actual uptake of like things happening in Slack again, which is good and normal. So yeah. We'll talk about it.
Okay. Have a good week.